temperature will shift the equilibrium towards the right as it involves the absorption of heat. The increase in concentration of the product Z. The increase in temperature of temperature favors the reverse change in an exothermic reaction and a forward change in an endothermic reaction. So formation of ammonia is another example. This synthesis of ammonia from nitrogen and hydrogen is an exothermic reaction. It is the Haber process. In the two has the reactants nitrogen and hydrogen. They have the total 4 number of molecules in the reactant sides and 2 moles of the at the product sides, and a lot of heat energy is evolved because it is an exothermic reaction. When the temperature of the system is raised, the equilibrium will shift from right to the left side with absorption of heat because it is the exothermic reaction, and it will proceed towards the left side. So this results the lower yield of ammonia. So if lowering of the temperature, if you decrease the temperature of the system, the equilibrium will shift to the right, which involves heat and raise the temperature. So this would increase the yield of ammonia. Similarly, if decreasing temperature, the rate of reaction is slowed down considerably and the equilibrium is reached slowly. Thus, if a commercial product of ammonia it is not feasible to use temperature which below than 500 degrees centigrade. So at lower temperature, even in the presence of a catalyst. There are another examples is equilibrium shift towards the right side or left side. In the first example, in the reaction, hydrogen and chlorine react to form the hydrogen chloride, and the 44.2 kilocalorie heat will be evolved. In this case, the equilibrium, because the heat is evolved, equilibrium will shift towards the left side. And similarly, when the methane and oxygen react together to form the carbon dioxide plus water, and the 22 kilocalorie will be heat evolved, and in this case the also equilibrium shift towards the left side. Carbon dioxide plus absorb the heat to form the carbon monoxide plus oxygen. In this case the heat is absorbed and equilibrium will shift towards the right side. Hydrogen and iodine, in this case also is a heat endothermic reaction. 12.4 kilocalorie heat is absorbed and to form the hydrogen iodide. In this case the equilibrium will shift towards the right side. So students, these are the two opposing reactions in which we discussed about the effect of temperature.